Hi you guys, I'd like to share a compound I made for diagnostics that I think some of you may find useful. And when you first go into this compound, the first thing you want to do is specify where you want your diagnostic files to be saved. And by diagnostic files, I mean a text file which is dumped out of this compound and a Bob file, a Bifrost object file that is also saved out of this compound. And the first thing you do here is you choose which directories you want to save your text file in and your Bob file in. So you just go over here and click on these parameters here and away you go. The next thing you want to do is publish the compound so that you can use it anywhere. And the way to do that is to right click on it and say publish. And that'll save the default sort of directories and file names that you assigned over here next time that you choose to insert this compound into wherever you want in your graph. So just to give you a little quick demonstration here, I'm going to go ahead and show you how this works. So this is in this text editor I have the text file that gets saved out open, and right now you'll see that there's really no values in these auto ports. And what these auto ports allow you to do is save out to your text file a wide variety of port types. So for example, I'm going to just put this string into auto 1, and then you'll see here in my text file that it was written to the file. You can also put it in an array. Since these are auto ports, they'll adapt to that. This is an array of floats, and it's also being saved out to the text file. Now, one thing to note, if you port in a multidimensional array, so anything greater than a 1D array, it will not write that to the text file. It'll say here array unknown data type. Now that doesn't mean that it's not in the object itself, it's just not being shown here as to what its actual values are. So you're going to want to try and flatten that array first, and then you'll have to sort of figure out where the primary indices are for it. So that's something to keep in mind. Another interesting thing to note here is that after you've saved out your published your compound, you can put it anywhere, like I said before. So let's say you're inside of an iterate loop and you want to diagnose what's going on at a specific iteration of that loop. And you would take, let's say for example, the current index, and then you could come in here and say, okay, if I'm on the very first index here, or 0 in this case, I want to build the text file. So I'm only going to write this text file when my current index is 0. And that's what this build if true means. Conversely, if you just want to say, hey, don't build this ever, don't deactivate, don't write this file ever, maybe because you're writing it in another part of your graph and you don't want this to overwrite your text file, you can just uncheck build if true. It's checked by default, but if you uncheck this, it deactivates this. Yeah, and I want to leave this deactivated because I'm going to jump back out to our outside of our iterate loop to show you what this is. Okay, so this allows you to actually write the properties to an existing object. In other words, to write these values, actually to set them as properties in the actual object that you may be working with. So here I'm going to take a mesh, I'm going to port it in here, and you're going to immediately see over here the entire object, the mesh itself with its standard properties that are part of it. And you'll also see all the auto ports listed prior, just like before. So basically, if you're not porting an object in, what's going to happen is it's just going to create a new object for you and assign it whatever ports you have. It's going to populate those ports. So if you bring in your object, it's just going to sort of append these to the beginning. And that's why these are named 0 auto, because it sorts alphabetically. Okay, now I want to shift gears and talk about the Bob, the Bifrost object, and how it works. One of the reasons why it's important to write out a Bifrost object is because I have found no way to read in a text file into Bifrost. And if somebody knows how to do that, I'd love to know. Yeah, but also it's just good to know how to read in a Bob, write and read in a Bob file too. So with the Bob file, there's this field here called Bob properties. And Bob properties, according to Bifrost standards, requires that they are delineated by a comma and a space, just like this. So you'll see I have these ports here, and each one of them has a name that corresponds directly with this name. So basically, if we go inside the compound here, we'll notice that there is a set properties that sets the property, 1_ points, and then it is then written inside the Bifrost object. There is a properties field there that is being piped in from, if we back up here, we'll see that same properties field here is being piped in. So it has that. It has the each one of these. So however you want to create your own properties to store with your Bob, you can do that here. Just add them in. Change the names of these if you'd like, but then if you do change the name, you're going to have to also change them here, because you'll see this just go in there, the key, and change it. And then, yes, there you go. That's why we do that. We have to have this one-to-one correlation between the names here that you want to save into your Bob and the properties here. So, yeah, like I said, it's important to save into the Bifrost object so that we can then read it in later. And when we read it in later, we can do visual diagnostics with it. So here, what I'm going to show you is in this node here, I'm reading back in the same properties that I set before. And this lets me figure out, do a graph. Actually, not do a graph. It lets me create the actual render in the viewport. So this is my viewport now. I'm not seeing the diagnostics that I want to see on this. The reason why is because I haven't, I haven't written them to my Bifrost object. So what I'm going to do is go ahead and do that here. Let's go ahead and just pipe in these points here, these normals here. Let's go ahead and put this in there. Okay, so that should be enough. Let's see what we got now. Yeah, there it is. Okay, so now when I take a look here, I'm actually creating these diagnostic points by reading in the Bifrost object and extracting the properties, which are the dot and the normals, and that's how this works. So, I can save out like I said, I have that build if true here, right? So if I was inside my iterate loop, I could just say, okay, hey, just show me what the first, let's just give you an example of that. I'm going to go back here and turn this one off, and then jump into here. Well, I'm going to go ahead and put these points in here so I can show you how this works. And we're going to go ahead and build just for the first iteration here. And we go back. Yeah, you can see there's the point right there. So it's just building it for the first point on the contour. Now this is just FYI, this is not ray casting. This is, you know, advanced contour detection. But you can get the idea here how this works now. I hope this has been helpful to you. Okay, see you guys later.